All right, guys, today we're starting section 14.2. This is product of powers. All right, and just as a reminder, in chapter 14, we are not using calculators, and that's because using a calculator really just kind of bypasses most of the actual knowledge and understanding that you need to have on exponents. It does the work for you. So we're eliminating calculators, but in doing that, you're not going to see ridiculous exponents that you have to evaluate. That's not the point of this chapter. The point of this chapter is to teach you the rules of exponents, and we can do that using small numbers, okay? So we're not trying to, make it harder than it needs to be. All right, so I want you to put a star next to this statement. This is really the core of the entire lesson right here. It says, to multiply powers with the same base, you add the exponents. So a couple things need to be present in the expression for this rule to apply. The first one is you must have multiplication connecting your bases together. So that's what you see here. You see all these dots in between the bases? That means that there's multiplication. Okay, so that's criteria number one, and we see it in all 6 of these problems. The second criteria is that 2 bases have to be the same value. So if it's a number, it has to be the same number. If it's a variable, it has to be the same variable. If it's an x and a y, that doesn't work. Okay, you with me so far? Sure. All right, so same base, I can use product of powers, and here's what it means. All right, this middle step that I'm going to ask you to show on your homework is not necessarily going to be points off on a quiz or a test, but for now it's really important while we're learning the rules that we write this step, okay? What I want you to do is I want you to write the common base, all right? So 3 to the 5th power times 3 to the 8th power, we have a common base of 3. And you're going to show me that you're adding the exponents that have the common base. 5 plus 8 is 13, so 3 to the 13th power is your answer. Thank God you do not have to evaluate that. Okay, that is your answer. All right, so we're just practicing basically this rule. All right, so I want you to try the next one. Based on what we just did on the first one, what is the common base, what are we adding, and what is our answer? Okay, so what's my common base? The next one down. 2 to the 4 plus 5 power. So 2 to the 9th power. 2 to the 9th power. Now, I want to add in something on the next one. I'll explain why in a minute, why the first -5 is not in parentheses. But just to not confuse anybody, let's put the -5 in parentheses. I'll explain why in a minute, why they don't have it. All right, and I'm going to take this opportunity to kind of time out on us real quick, and I'm going to review with you the rules for a negative number raised to a power, especially for those of you who weren't here for 14.1. There is a difference between -4, again, this is completely different from what we're about to solve, -4 to the 2nd power and -4 to the 2nd power. Someone raise your hand and tell me what's the difference between these two terms. Someone raise your hand and tell me. Miles.
First one's going to be -.
Okay, well, what is in one that's not in the other one? The parentheses, okay? So which one of these would have an answer of -16? Isaiah?
The left one.
The left one, and here's why. Because when the base is not in parentheses, it means that you evaluate the exponent. So 4 squared is 16, and then your answer is automatically negative. It doesn't matter what the exponent is. If that negative base is not in parentheses, your answer is negative, always. If it is in parentheses, that means -4 times -4, which is positive 16. Okay? So now, let's kind of backtrack. Yes?
So that 5 has to be in parentheses?
Yeah, just to make it clear on what I'm supposed to write in my answer. Okay, so here I have a common base of -5. But now I need to talk about what happens when there is nothing written in the exponent. Does that mean it's 0? No, it means there's a 1 there. There's an understood 1 where the exponent goes. So the reason they didn't have -5 in parentheses is because there was an understood exponent. If there had been an exponent there, they would have. But for me, just consistency, I want to see those parentheses. So I know it's 1 plus 6, which is -5 to the 7th power. All right, so here's the bummer. If -5 is in parentheses in the original problem and you forget it in the answer, that actually is wrong, because a negative base in parentheses or not in parentheses is a huge difference, right? Okay, so just make sure you remember that. Okay, let's come up here to my x's. All right, so now they're x's, but they're instead of numbers, but I still treat the rule the same way. Same base, I write my common base, and I add my exponents, x to the 10th power. Okay, I want you to try the fractions, all right? We treat the fractions the same way that we treat all the other problems, expressions that we just solved. Okay, so anybody know what they got or want to volunteer their answer? Gabe?
I got negative 1/2 in parentheses to the ninth power. Yeah.
Yes, very good. And did you put the parentheses? Yes, parentheses are important. Okay, so based on what we said a few minutes ago, I want you to now answer the last problem. So what'd you get for your answer? Yes, z to the 13th power. Z to the 13th power. All right, any questions, guys? Product of powers. Any questions? Okay, example 2 now is going to deal with finding a power of a power. Okay, now this is different from example 1. And I'm going to explain it. All right, you guys ready? I'm kind of shifted down to example 2. Power of a power is different because you no longer have 2 bases being multiplied together. You only have 1 base with an exponent or a power being raised to another power. In this case, you are going to multiply the exponents together. All right, so this section of your quiz and test is very much going to be, because examples 1 and 2 would be together in the same section, when do you add the exponents and when do you multiply them? Okay, so we need to be able to tell the difference. If there's 1 base being raised to a power and then another power, I multiply. If there's 2 bases with exponents, that's when I would add my exponents. All right, so 3 to the 12th power, not 3 to the 7th, okay? So what about W? What about W? A power raised to a power, I would multiply, and it would be, Caden, W to the, okay, but it's a power to a power, Xavier, W to the 20th power. So you have to know, guys, you have to be able to recognize, if this is a power of a power, 1 base, exponent being raised to another exponent, I multiply. All right, I want everybody to do this top right problem. Compare your answers with your group mates. I'm only going to give you maybe 30-ish seconds. All right, guys, what is it? Tell me. Y to the 8th power. Who got y to the 8th power?
Me.
Y to the 8th power, because you're not talking about unrelated things.
Yeah.
Okay? Y to the 8th power. Now, what do you notice about the last problem on this slide?
It's weirdy.
Yes, there's a parentheses inside a parentheses. This is significant. Here's why. Because the -4, there's a negative base, and it's saying that this base is what's being raised to the 3rd power and then the 2nd power. So in my answer, I'm going to keep -4 in parentheses. If I leave it not in parentheses, that is wrong. That's not correct. I must put it in parentheses. Okay, so I just want to show you the difference, guys. This is when you would not put it in parentheses in your answer, okay? So you say, well, -4 is in parentheses. No, it's not. The parentheses here is separating the powers, okay? It's not actually putting -4 in parentheses. There is a difference. So that's when it would be -4 to the 6th power. All right, are we good on example 2? Yes. Now you can say yes. Okay. All right, so now I want to show you one more slide that shows us the difference on when you're supposed to add the exponents and when you're supposed to multiply them. Okay, so look at the first one. You see 2 bases being multiplied, so would you add the exponents or would you multiply them? What would you do? You would add them. Very good. So that's going to be x to the 7th power. Okay. Now on the second one, would you add your exponents or multiply? Tell me. Multiply, because this is a power, 1 base, being raised to another power, x to the 12th power. X to the 12th power. Okay. Questions on that? So we kind of see the difference. All right, one more example, example 3. Finding the power of a product. What does that mean? The power of a product. Well, here's where the product is. It's inside the parentheses. This is 2 times x together, making 1 term. So what I have to understand is, and here's the common mistake. Oh, my answer is 2x to the 3rd power. You know, I just raised 2x to the 3rd power. It's not so, though. You have to recognize that you're actually raising each term individually to the 3rd power. All right, so here's what I want you to show in your notes and your homework, okay? This is not necessarily, you don't necessarily have to show this on your quiz and test, but I want to see it at least for now. This is 2 to the 3rd power times x to the 3rd power. Okay, do you see that? You're raising each term inside the parentheses to that exponent. And now there's actually part of this that you can evaluate. Now again, we're not going to get crazy with it. All right, we're not really going to see like these numbers in the thousands or anything like that. But can I evaluate 2 to the 3rd power? Yes. Absolutely. What's 2 times 2 times 2? 8. And now you bring it back together. No dots in your answer. Bring them back together and you say 8x to the 3rd power. You can't evaluate x. Okay? 8x to the 3rd power. All right? So I want you to try to write the expanded version, and you might even be able to solve it and put it back together. But try on the next one, 3xy to the 2nd power. All right? Here's what your answer is not while you're working. Your answer is not 3xy to the 2nd power. Okay? You don't just poof, the parentheses go away and just put to the 2nd power. There's more to it than that. All right? Believe it or not, I still had, by the time we got to the test on, you know, the 8th graders taking this, sometimes we still had some of those struggles. So don't do that, okay? We're raising each term individually to the 2nd power. All right, did you write 3 squared times x squared times y squared? Yes. Okay, which part of that can be evaluated?
3 squared.
3 squared to make? 9x squared y squared. No dots, everything together. No spaces either. I've seen this, 9x squared y squared, like this, and then a boxed in answer. I mean, I wouldn't say that that's wrong, but you don't need those spaces in between the terms. Just write them all together so it clearly looks like one term. So don't do it that way. All right. Let's come up here to 5y to the 4th. All right. So I'm not going to lie, 5 to the 4th power. You might need to do a little bit of hand multiplication, but it's not a huge deal. Okay. Go ahead and evaluate that. Guys, 5 to the 4th power is 625y to the 4th power. All right, what did you get for the last one? Sarah, what did you get for the last one?
8 to the 3rd power and 2 to the 3rd power.
Very good. And this is how the breakdown happens. It's each term inside being raised to the 3rd power, and then I can evaluate 2 to the 3rd power. All right, one more question for you, and for some reason on your notes, it like flips over to the next page, and you have just have that one line. Can you use the product of powers property to simplify 5 squared times 6 to the 4th? Explain your answer. So if it's yes, tell me why. If it's no, tell me why not. Go ahead and answer that question. You guys can discuss among yourselves. Okay, let's see. Avery, what did you say? Yes or no?
No.
Okay, you said no. Why? They don't have the same base. I said no common base. Same thing. Something about the bases being different. All right, I'm going to give you one more. Can I use product of powers here? Someone raise your hand. Can I use product of powers? Yes or no?
Yes.
No.
What? Addition.
Yes. Okay. Because, okay, so y'all look straight to the base, right? We do. Okay, hold on. Time out. Let me talk. We had a common base, and our eyes are immediately drawn there. We say, oh, there's a common base. I can add them. Not when it's addition. It has to be multiplication. So, no, I can't do it here either. No, because it's addition. It's addition. Okay? You don't have to solve it. We don't have to worry about that. Okay? If you understand that, this is everything we need to know for 14.2.